Okay, so we're connected to the router through the laptop through our console cable. Left click on the laptop's icon and we connected to terminal, and we're here in the terminal view. So how did we do that? Here, I will go back and revise this. So connected to console cable through connections, left click on the laptop, go to terminal, click OK, and we are now here configuring this router. I was in privileged user mode. I type exit. I was in privileged user mode here. I typed enable. Take me to privileged exec mode because I want to find out as much details as I can about this router without being limited. So the next thing we're going to do, so show MAC address table, showed us the MAC address table on the switch because the switch deals with MAC addresses. Now, when we were on these PCs, we went to command prompt and we typed ARP-A, which showed us the ARP table. Well, what if we want to see the ARP table of this Cisco 2911 router? The command is show ARP or show IP ARP. Show IP ARP. Okay, right now we have nothing because there's nothing configured. What if I wanted to see all the interfaces like I did on the PC 0? We had the fast Ethernet 0 interface and we had the Bluetooth interface. This router also has interfaces. If you go to physical tab, I'm sorry, you can't see that here. Well, here I'm going to left click on the router and try and look at it from a physical view. So if you look at this router, I left click on the router. This router has interfaces. So if we wanted to see, let me close this, back to the laptop and the terminal view. If I wanted to see all the interfaces on the router, what command will I type? Command will be show IP interface. Interface. And I want a brief summary. So I say brief. B-R-I-E-F. I can spell. Show IP interface brief. Here it is. Brief summary of all the interfaces. G00, Gigabit Ethernet 01, Gigabit Ethernet 02. We have a VLAN 1 interface. There are no IP addresses assigned, so this is unassigned. They are there, they exist, so yes. Their status is administratively down. Protocol is also down. Status is administratively down because it's turned off. It doesn't have an IP address assigned to it. So I'm going to assign an IP to this interface, G00, because that's the one we're using here. And I will also turn it on. So to do that, we're going to go to configure terminal to go into global configuration mode. So we're going to proceed with our configurations. So I will type interface Gigabit Ethernet 00. Press enter. Now we're in interface configuration mode. Under interface configuration mode, I will type IP address. I will give it an IP address. IP address 192.168.1. It has to be on the same network. So I have 1, 2, 3, 4. Let's give this 5. 1.5. Same subnet mask. 255.255.255.0. Let's enter. I have no shutdown. Turn on the interface. And there it is. Interface Gigabit Ethernet 00. Change state to up. What does that mean? It turned on because I typed no shutdown. No, if it's shut down, it's shut down. It is administratively down. It is turned off. Red symbols turned off. When it's turned on, it has changed its state to up, which means it should stay up. Let's go check. Alright, I hit tab or enter. I exit this mode, exit again, get out of global config, and show IP interface brief. There it is. Gigabit Ethernet 00, 192.168.1.5, and status is up. Protocol is up, so we can communicate. What if I want more details? What if I want to check my subnet mask and make sure I typed it correctly? Instead of giving a summary, learning about a summary with show IP interface brief, I can get the full details like we did on the PCs, IP config space /all. It's not the same on the Cisco devices. It's show interface gigabit Ethernet, whatever the interface's name is, 0/0. Press enter, and there it is. We have internet address 192.168.1.5/24. That's the 255.255.255.0, 24 bits in this IP address. So so far so good. Now let's check our ARP. Show IP ARP, our ARP table. Wait a minute. Wait, we know about ourselves. 192.168.1.5, and this is our MAC address. Oh, how cool is that? What about show ARP? Show ARP. Same thing. The two commands do the same thing. Okay, so here's the MAC address. And here's my interface that goes along with that. Gigabit Ethernet 00. But what if I wanted to ping one of these devices? Would I still get a broadcast? Let's find out. Go to simulation mode. I make sure ARP and ICMP are selected. We would go to edit, check these two boxes, close it, and I'm going to go back to the laptop. And what I will do is I will ping PC2. So ping, and hey, we're on a router, but yet we can still use ping. 192.168.1.2. Press enter. ICMP echo 2 192.168.1.2. Minimize and hit play. Here we are. Will it broadcast? Wait for it. Yes, it will. Boom. There's the megaphone. We're trying to figure out the MAC address of this device, and it's the only one that responds and says, yes, I have 192.168.1.2. Here is my MAC address. Now we can speak privately. Okay, so if I go back to real-time mode, well, let's see. Will it speak privately or will it send it out on broadcast? I'm pretty sure this router is now sending specifically to the MAC address of to the switch to send it to this PC. And there you have it. Okay, let's go to real-time and well, wait. What's the proof that the first thing was an ARP? I saw the broadcast. Okay, so if I slide over to the right and I scroll all the way up, and let me pause this. Slide all the way over to the right, scroll all the way up. We wanted to send an ICMP from the PC. Okay, and from the router 0. 192.168.1.2 was the destination. 192.168.1.5 was the source. We did not have the 1.2's MAC address in our ARP table, so we sent an ARP request. All F's, which indicates that we want to use that. We're sending a broadcast. We're using a megaphone. Okay, and eventually we got a response, and we were able to communicate privately and send those ICMP packets, those ping messages. So let's go back to real-time mode, and let's do a check of the ARP table on the router now. So I go back here to the router, say show ARP. There it is. 192, IP address 192.168.1.2, and here's the MAC address. 7 ends in 7A3E. Let's check. Is it true? Go to the PC, and I mean it's already here. You can see it, but I want to find out. Sure, maybe someone was in here doing some shenanigans. So ipconfig space /all, and there it is, fast Ethernet 0, 7A3E, IP address 192.168.1.2. Back to the laptop to look at the config of the router, 192.168.1.2, 7A3E. Now this PC knows that if it wants to communicate on layer 2 through the switch, it has to communicate using this MAC address. Okay, alright, so that wraps up switches. So let's just do a quick recap. We said MAC addresses are like VIN numbers. So what is a VIN number? VIN numbers are it's a 17 character number. A VIN number is composed of 17 characters that acts as a unique identifier for a vehicle. Okay, now what does it tell you? It tells you where the vehicle was built, the manufacturer, the engine size, and so on. It tells you a lot, all in these numbers. Well, if this was a computer, we would be talking about MAC addresses. MAC address also tells you it's a media. Let me scroll down for a second. I just Google searched what is a MAC address. Media access controller address is a unique identifier assigned to a network interface controller for use as a network address in communication within a network segment. Okay, now let's look at this for a second. If we go down here, we learn a little bit more about MAC addresses. I'm scrolling down because I want to get to this section. So computer A wants to send an IP packet to computer B, but it doesn't know the MAC address of computer B. Computer A will then broadcast an ARP request received by all computers on the local network segment. The request will essentially say, this is my IP address, this is my MAC address, and I am looking for the MAC address associated with this IP address. If this IP address is yours, please respond and give me your MAC address. Why? Because I want to have a private conversation. So this is what happens. Local network segment, ARP request broadcast for destination MAC. And once they get the MAC, communication happens privately. So computer B receives the ARP request and will do two things. First, every device has its own ARP table. Each time a computer wants to send a packet on the LAN, it will look in its ARP table first. If an entry for computer A does not already exist in computer B's table, it will make one. It will add computer A's MAC and IP address based on what is in the frame. Then it will send an ARP reply with its IP address and MAC address. Computer A will receive a reply and the info and add the info to its ARP table. With the right MAC address, computer A can now send the Ethernet frame to computer B. That is the basics of how computers communicate through switches on a network segment privately. Thank you, and next we will be talking about routers.